In this video, we're going to talk about some synthesis strategies from Chapter 9, and in particular, we're going to focus on converting between alkenes, alkynes, and alkanes. Okay, in this chapter already, we've looked at ways of converting alkynes and making them more substituted. So if we just react them with hydrogen in the presence of a metal catalyst, we can go all the way from the alkyne to the alkane. And then if I use poison catalysts or dissolving metal reduction, I can go from the alkyne to the alkene. And then, we learned both this chapter and the previous chapter, I can then react the alkene with hydrogen and a metal catalyst to go to the alkane. But can we go in the other direction? Well, we've talked about this a little bit. So we saw in one of the first videos in this chapter how we could prepare an alkyne from an alkyl dihalide. And we did that by reacting it with a strong enough base. And then if we were going to make a terminal alkyne, then we had to add water to protonate it. So if we start with an alkene, I can do a halogenation reaction, where in this case I'm adding bromines to my alkene. And then I can react it with a strong base and water to turn it into an alkyne. So now we filled in a lot of this puzzle. So we know how to go in this direction, and we know part of the way how to go in this direction, and in Chapter 10, we'll sort of fill in this last blank. So let's finish up this video. And so to finish up this video, let's look at a couple different examples. And so I want to propose a synthesis to accomplish the following transformation. And so essentially what I've done here is I started with 1, 2, 3, 4 carbons. I now have 1, 2, 3, 4, 5, 6 carbons. So I've effectively added an ethyl group here. And so I've added a carbon-carbon bond. The only way that we've learned in this chapter to add carbon-carbon bonds is with alkylation of a terminal alkyne. So I don't know how to do alkylation with an alkene, but I know how to turn this into an alkyne. And then once I do that, I can use the terminal alkylation to add on these two carbons, and then I know how to go from an alkyne to an alkene, and I can do that with hydrogen and a poison catalyst. So the first thing I want to do is halogenate this. So if we react it with Br2 and a solvent we often use for halogenation is carbon tetrachloride. And so that's going to give me an alkyl dihalide. I can then turn that into an alkyne by using a sufficiently strong base, and we usually use sodium amide. And then I'll react that with water, and that's going to give me this compound. So then if I react that with the strong base again, which will deprotonate the hydrogen from here, and it'll turn it into the negative ion, which is a good nucleophile, I need to add an ethyl group. And so if I react that with 1 iodoethane, that's going to attach the ethyl group onto here. So that's going to give me this compound. And then my last step to go to the alkene again. And so I want to add the hydrogens here and here. So I want to do a cis addition. And so I can do that. And I don't want to go all the way to the alkane. So I need to use a poison catalyst. So if I use H2 and Lindlar's catalyst, I can accomplish the job. In this example, we want to convert an alkyne into an alcohol. Now, we haven't learned any reactions where we can add an OH directly to an alkyne. If we try to do hydration, we're going to get either an aldehyde or a ketone. So in this case, I think our strategy should be to first turn our alkyne into an alkene, and then we know lots of ways to add an OH to an alkene. Now, this is a terminal alkene, so the product is not going to be stereoisomeric, so I could use either a poison catalyst or dissolving metal reduction, and it doesn't really matter. I'm going to go using sodium and ammonia, and so that'll give me a 4-carbon alkene. All right, and then once I have this, in order to get to the final product, I want to add the OH in anti-Markovnikov fashion, so I want to use hydroboration oxidation. So I would add BH3 in THF, and then in the second step, hydrogen peroxide and sodium hydroxide. And that'll give me the final product. Okay, so in this example, I'm starting with acetylene, and I want to make this compound. And so this has 4 carbons in the chain. This only has 2, so I'm going to need to do 2 alkylation steps to add a methyl group to each side. Then I think if I convert it into an alkene, I can then use syn dihydroxylation to add my 2 OH groups. So first, let's add a methyl group. So if we use NaNH2 to deprotonate my alkene, turn it into a good nucleophile, and then if I react that with iodomethane, that'll add a methyl group to one side. If I do that again, I can add a methyl group to the other side. Now, I think there are a couple ways I can go from here. This looks like it probably started with the trans alkene, although I think there's a way we could do it with the cis. So if I want to convert the alkyne into the trans alkene, I'm going to want to use dissolved metal reduction. And so for that, we use sodium dissolved in ammonia. So that's going to give me the trans alkene. And now I want to add the 2 OHs to the same side. Right? They're both wedges, so I need to do syn addition. And so there are a couple ways to do that. One would be to react with this osmium oxide compound, and then a co-catalyst, and that should finish the job.